How ironic
my
that you claim other
observation
people
that I
don't have
described.
It
discipline.
just
'cause you
shows
don't
that
have
he's not listening to you prior to when he
so
starts.
That's the
speaking
irony.
either.
we're just
That's the
dictating and
irony.
finger
He's
wagging
trying to
at this point.
dictate to me what I've experienced in the years I've been debating dozens upon dozens of these adherents of scientism. That's the irony. He's gaslighting me in my recollection, in my reiteration of my descriptions of my observations in my participations of these debates.
That's incorrect. Also,
So,
I've given
like, I think we
solid.
can.
Go ahead. Sorry.
Well, I mean, you guys are just going to start. You're just finger wagging at each other and calling each other names at this point. So I'm going to try to establish this into a question and a conversation as best I can. And this is going to be pointed at Zanick. Do you think that science solves the human problem? I'm being very concise, but presumably you understand what the human problem is. You're welcome to sort of ask the question about that or whatever.
I would love to hear about.
Do you think he's going to ask the question about it? Just define what it is.
Well, no, because I mean, this is what science was set out to do initially when Francis Bacon was, going about it, right? He wanted to reduce the amount of myth and superstition within humanity in order to essentially sort of get at the heart of reality.
So you're saying the human problem is myth and superstition?
Well, so yeah, this is what the science was initially set out to do. This is what the whole time of the Illumination was said to be about, right? And then what we're trying to point out. Yeah. But what we're trying to point out effectively is that, well, if the science is being used in such a way that it is causing these gaslighting things that you can't trust your own human senses, right? Then what I'm putting forward is that if science proposed itself initially as to be a remedy to the human problem, that of the creation of myth, men being liars, gamblers, so like if you had a powerful person with a delusion, they might be able to influence a lot of people around them. So science was trying to remove that problem, essentially. But what we actually find in reality is that, well, this scientific method is actually seemingly contributing to a lot of superstitions and creating a lot of myth. We've seen this in the false scientific
I hope you don't
claims.
mind if I come in here to just point out the fact that when something is accepted within scientific consensus, it means that it's been replicated independently from the original claim, right? That's what we're talking about here.
That's not necessarily an intent at all.
Do you
was
think
that Rich speaking, or was that like an alien from another planet talking?
Does science solve the human problem? Is what I'm trying to get at. Right back to the start.
Yes, science is better. Science does a good job of eliminating lies, because if someone can't follow your experiment to a T and get the same result, there's an issue.
That's not a human problem.
I
wanted to point out something that somebody just mentioned.
He said that the human problem was this superstition and myth overtaking it, and science was supposed to solve this. And what I'm saying is that having an independent body as like a scientific journal with peers reviewing the papers and doing the experiments.
That's the problem, though, Rich.
The vast majority of the distinctives of your world.
That's a problem, though, Rich, because
that method.
Original science, Gregory, I know you heard me trying to get in. Thank you. Original science is not based on consensus-based science, bro. So I don't know where you got that from, Rich, but that's current modern science. That's not original denotative science.
And I will argue the consensus thing too, because there are a lot of science, even today, that has scientists on both sides. There might be more or less on, and it doesn't mean one of them is more right than the other, because really it goes down to what they're actually claiming, who's actually agreeing with them, that kind of thing. So things that are debatable.
I don't.
There are a lot of.
No, that's not true.
In my world,
that's not a fact. That's not a fact. Truth is Now, truth is doesn't. I don't know why you keep interrupting me, bro.
Because you said I was not a fact. What's not
Stop.
a fact?
He's got to talk, dude. Truth is independent.
It does seem like I can go back and forth, I think, pretty easily.
He's answering you.
Zanick.
What I'm trying to tell you is truth is independent from consensus.
That's what I said. I started out by saying that. That's why I questioned you.
I would just like to also point out. I would just also like
affirming the consequent.
Hilarious, because I already taught him modus ponens like several weeks ago.
I gave you modus ponens in my. I put in your form that you wanted, that you taught me. There you go.
You didn't. You affirmed the consequent.
If you're doing modus ponens, modus ponens, which is the one you said, P implies Q. P is true, therefore Q must also be true. So in your thing, Earth rotating, Earth is rotating ball, P, implies that the pendulum will precess. Okay, Q.
Right.
But the next one is P is true. So the Earth rotating is true. Therefore, Q. But you haven't proven the Earth is rotating, so you haven't mixed up. You haven't proven the Earth rotation.
Oh, that fucking thing. Whatever that is doesn't do anything.
That was better.
You're just saying Earth's rotating. That's it.
Right. That was actually saying Earth's rotating. And you're just begging the question the entire time.
Well, he formed the modus ponens. It's if the Earth is rotating. It's not Earth is rotating, therefore.
Correct. That's a good point.
Yeah, we know what a conditional premise is.
Well, that's
said
how
the conditional premise, and then affirm the antecedent. Then affirm the consequent in the successive premise after the initial conditional premise. That's affirming the consequent.
Right, because the problem with it is that there could be another reason the pendulum is precessing, so it could lead you to the wrong conclusion that it's Earth rotation. That's the problem, and you're just left with the wrong answer, which is not what good logic is meant to do. If it leaves you with a problem, like it's something that's not the right answer, that's why it's a fallacy.
So we can
so we taught you modus ponens again.
Then we can rephrase it.
And taught you affirming the consequent fallacy again.
Then we can rephrase it.
You just keep getting it wrong.
Then I can
just prove that you don't know how to think soundly about the issues.
No, I get it. You have
just
a valid
insist
objection.
on lecturing everyone about the issues.
You have a objection. I valid. I get it. I like the way Gio phrased it. Let me respond with a different one. So can we all agree that a freely swinging pendulum will maintain that plane of oscillation unless acted upon by an external force? Would you accept that?
Why are you asking the question? Say your syllogism. You failed the first time.
No, this is the major premise. And
your argument doesn't need our concession.
Appears to rotate over the floor over time. That's what we do see. We all agree that, I think.
Your argument doesn't need an interview to us, dude.
Or reference frame must be rotating beneath. Okay, I can't do this anymore. You're trying to nail me to the wall, and I'm obviously moving around too fast or something. Give me too many gladiator moves. I don't know what the deal is. It's not working. So I've given you what you wanted. You don't like it. You say it's affirmative consequent. Fine. You win. I lose. Okay, great.
I just learned.
Can I say something for clarity?
I mean, Gregor, you did just interrupt him there. You could have given him 20 seconds, but I mean, because he was trying to say something.
Because we don't need to be waterboarded with his interview. He needs to be saying an argument.
Oh my God. Really?
It is a bit of waterboarding talking to Zanick.
He's waterboarding me.
Come in and he doesn't stop, and you're just.
I'm the persecuted. What are you talking about? I'm the little guy here.
You did get interrupted. Did you want to say your point, or should we let SE get?
I get where he's coming from, and there is a little bit about this and I've always agreed with Gio and everybody else that a lot of this is affirmative consequent. A lot of the things we actually use as evidence has a level and a degree of affirmative consequence in the logic.
You admitted you're wrong.
I'm not wrong.
No.
I gave you another. I put it a different way. I said,
you don't know.
If the objects stay in motion in a straight line until acted upon by their force. In other words, the focal pendulum is set up and it's freely swinging back and forth in a single plane. In order for it to precess, there has to be some forces acting on it, some pseudo forces specifically acting on it. Would you not agree?
If you admit that a lot of your appeals are affirmative consequent, you're admitting that you're appealing to fallacies, fallacious argumentation, which proves you don't know your beliefs.
Well,
simple as that.
I do know that they're not beliefs. These are laws of nature.
You believe the proposition.
These are laws of nature that there are no exceptions to. For example,
hang on, Zanick. You said earlier yourself that pseudo forces are illogical, and now you're trying to bring them in.
Right.
That's the problem. Right.
Before we get into that, let me say something real quick, guys. 10 seconds, right? Because there's a misconception that everybody says. I used to say it too. The pendulum does not precess. The pendulum moves back and forth, and the story goes that the earth moves underneath it, okay? Mm-hmm. The pendulum has to swing back and forth. The pendulum does not precess. For the sake of the audience.
That's not true, actually.
No, it does, because it's still called precession, even if they think it's like if the Earth is stationary and then the pendulum's precessing, then it's the pendulum that's actually moving across the stationary Earth. If it's a globe or whatever and it's spinning, the globe is spinning under it. But I think SC, like the term, like saying the pendulum precesses, even in their globe thing, I still think that. I mean, doesn't that? I guess I don't know 100%, but doesn't that still work? Like, I was actually gonna because technically, wording wise, the pendulum is precessing, even if the cause is the Earth rotating. Like, I think you can still call that the pendulum is precessing.
Gio's right.
Hold on, Zanick, please. You've been talking for a while. Not technically, because according to the story of the pendulum, right, as pertained to the spinning Earth that it proves, the pendulum has to move back and forth in a straight line, right? And it's the Earth that moves underneath. You know when they show it in the museum and it knocks off those things. So it's incorrect to say that the pendulum processes, but everybody says it that way.
It's really not the Earth moving underneath it either, because you could have it go not precess at all at the equator. So proving wrong that assumption. What they were trying to say, SE, is that the precession is this perceived. You can think of precession. I'm could have sworn I was in the middle of a sentence. Is that great?
What you should really say is that the Earth is precessing, actually, because here I just looked up the definition of the word. The definition of the word. Yeah, I know, but I think you could still word it that the pendulum. Well, okay, so here the definition of precession. A comparatively slow circling of the rotation axis of a spinning body about another line intersecting it. So the line would be like the pendulum going back and forth, and then the comparatively slow circling of the rotational axis of a spinning body, and this would be the globe. So wording-wise, do you have to say the Earth is precessing with Foucault's pendulum, or do you have to say the pendulum is precessing, or do both work wording-wise? That part I don't know.
No, both don't work. Both don't work, because according to Foucault, it's the rotating body underneath the pendulum that's rotating, and the pendulum has to be moving back and forth, or else there's no reference to it. So technically, you have to say that the Earth is moving, which I don't believe. I'm just saying, according to Foucault, the correct thing is the Earth is processing.
Okay, well, if that's the case,
pendulum.
Okay, if that's the case, then I should be at the equator, and I can have the Earth rotate, and have no precession occur. So then rotation does not cause precession. So that whole claim is incorrect. There is a rotational component involved, but it is something that is 100% at the North Pole, and that value goes way up as you go to southward to the equator or northward.
You're just wordsmithing it now, bro. You're just
I'm not wordsmithing it. If the Earth rotates, and at the equator it does not precess at all, so it can't be just due to rotation alone. It has to do with this rotation and the theta angle. It has to do with the angle as well.
You just simply don't understand it, bro.
No, okay, but you included in that the rotation of the Earth in your own rhetoric.
I know you mean well.
We heard you. You just included the rotation of the Earth in that. That's what you're trying to prove.
Then put it in modus tollens. Go ahead.
No, I'm not going to argue for you. What the fuck?
No, you can put that in modus. You can do your own version of that. Because if you're gonna determine its rotation, and I'm gonna give you a situation where it's not true. If it rotates, then precession, and I can give you a situation where it doesn't rotate. Doctrine? So it's not. It has to be. You have to include latitudinal position with the rotation. Otherwise, your whole premise is shot.
Yeah, included. You're trying to prove the Earth is moving. That's included what you're doing.
Rotating.
Moving. It's a type of motion.
Not really.
What the fuck you mean not really?
It's moving. You can have a spinning ball sitting on a fixed thing. It's not moving. It's just rotating.
That's a type of motion. What is wrong with him?
Moving. Its center is not moved.
Like who here agrees with that? That rotation is not a type of motion.
It's a type of motion of the sphere itself.
It's what I said.
Are you saying there's no such thing as conservation of angular momentum, Zanick?
Of course there is. That's the rotation of the surface. You say the Earth itself rotating.
I don't know, SC, they definitely say the pendulum. They do word it, the pendulum precesses, like in the wording of this.
I know they do, but it's incorrect. It's technically incorrect.
According to you.
No, according to bro, the whole thing. Why the proof that Foucault gave that the Earth is moving is because the pendulum is moving back and forth with relation to the Earth moving. This is not rocket science, bro. This is a kid's toy. You need the pendulum to be moving in a linear motion in order to say it's relative to the Earth spinning. Why is this difficult?
Well, because the word precession. I'll give you the answer. I'll give you the answer. No, I'll give you the answer. Precession is a perceived motion. That's what precession means. It looks like the Foucault pendulum is rotating, but it really is the dial underneath it that's rotating. I agree with that.
That's what I just said.
I know you're not wrong, but you're getting a little pedantic in saying where you can't. And like I said,
the irony of calling pedantic
as the focal pendulum is precessing. That's technically what's happening. It's a perceived motion. It's not really. It's not a real motion of that plane. That plane's not moving.
You can't make any progress.
I don't think perceived.
I was waiting.
Go ahead. I don't think perceived.
I just want to say, I would like people to stop using this pedantic terms, because in these rooms when we're having these conversations, we have to be pedantic.
Yeah, to be precise. All right.
Yeah, so I mean, I don't think the word perceived, Zanick, necessarily is connected to the word precession just because you perceive it. Because precession, I read it earlier, a comparatively slow gyration of the rotation axis of a spinning body, that would be the glob, about another line intersecting it so as to describe a cone. That's actually one of them. The other one is similar, except it doesn't say a cone. It's just an axis of a line. So yeah, I did bring it back up because Essie brought it up, but I'm just saying, like, if you did have a big spinning thing underneath a pendulum and the pendulum was just swinging back and forth, there is precession occurring because you have a spinning thing and then the straight line axis of the actual other definition, the one I was a little bit better. Hold on. Right here, a comparatively slow circling of the rotational axis of a spinning body about another line intersecting it. So the line is the pendulum going back and forth, and then the Earth, in that theory of it, the Earth is rotating under. But is the wording that you have to say the globe or the spinning axis body is precessing, or is the pendulum precessing? Now, Essie's trying to say because the pendulum's okay, but I'm not sure that's actually, like, in terms of the English language, though. Like, you might be able to say the pendulum is precessing because the pendulum is the straight line that's just going back and forth, the globe going under. That's all I'm saying. And it seems like in all of the literature, like they say, like right here, these calculations show that the pendulum's precession period varies with latitude. Like they call it the pendulum's precession period. So anyways, I'm not trying to like
critiquing. That's what
I'm kind of
critiquing.
Yeah. Like, I mean, what they claim is happening. I hear you, Essie, on that. The wording, another time, if we don't want to harp on
Essie's critique is that it's analytically wrong.
Yes, exactly. It's analytically wrong. It's a wrong statement.
Well, it says
given
here,
the meaning of precession,
it says here, yes,
what they're calling is precession is wrong.
It says here, yes, the precession of the focal pendulum, the slow rotation of the swing plane, is an apparent rotation from our Earth or perspective of Earth, demonstrated that the Earth itself is rotating beneath the pendulum, which tries to maintain its fixed swing plane in inertial space. So it's saying, yes, the precession of the focal pendulum is that apparent rotation, is the perceived rotation.
Yeah, like Essie, let's say we were doing an experiment in a lab and we had a ball, a 5-foot radius ball, and we spin the ball, and put it on a little motor and the ball's spinning. Then we take a pendulum and we put it, of course it wouldn't really work on a ball because it would fall off the ball, whatever. But let's just say you hold the pendulum, you suspend it over the spinning ball, and then you swing the pendulum back and forth. In this case, the pendulum would not be moving. Let's say you have a motor that just makes it go straight back and forth. And if we did that and we're going to write our paper now, what I'm saying is that in that paper, would it be technically valid to say this pendulum is precessing, even though we have a spinning ball underneath the pendulum that's swinging back and forth? That's the thing. Because, I mean, in the mainstream kind of world of it, I mean, they say it is the globe spinning underneath it, but they say the pendulum precesses. So I'm just saying, if we published a paper, would it be valid for us to say, hey, this pendulum was precessing in our little 5-foot ball experiment?
Not if it was moving back and forth. Let me explain this like as simply as possible, right? And you'll understand it this way. When they do this said experiment, right? Do they not tie it to a string and burn it? They do that, right?
Yes.
Now, the reason why they do that is they want to make sure that it falls in a straight line. That's the whole reason why they do that. So, I mean, it's just a technical statement, but the whole idea is that pendulum has to move back and forth in a straight line in order for the relative motion of the said Earth to be measured. Otherwise, if the pendulum is moving around, processing, and the Earth is spinning, then what do you have exactly? You have nothing. That's
what the stationary Earth description would be, is that the Earth is at rest and then the pendulum is precessing.
That would be a different story, yeah.
Yeah, but I just not to be overly pedantic, but I just think the wording, like saying the pendulum is precessing, might be valid if it's a ball spinning under a pendulum, or if the pendulum is actually moving around, like doing it on a stationary Earth. I'm just not 100% the wording, like the absolute, or if there is like a for sure technical of which one. It's kind of like the pejorative, or like which, or not pejorative, but the like the naming of which is the thing that's processing. Like if I went and if I say, hey, you went and played baseball, and you're like, well, no, the baseball played you. You know what I mean? It's like which one is the correct like naming?
So bottom line,
it's a wording.
The appeal to Foucault's pendulum as though it's exclusively indicative of the notion that the Earth is doing axial rotation. It doesn't. We all know it doesn't. And then tried to supplement that by acting as though the only other option is impossible. And I told him to specify the mode. He never specified the mode. He still doesn't understand that metaphysical concept. And then I told him to say the syllogism to make his argument entirely conspicuous, and he failed to do so. He contrived one argument, called it modus ponens, and didn't even say a conditional premise, let alone affirm the antecedent to then conclude with the consequent. He affirmed the consequent. Then we had to teach him the difference between modus ponens and affirming the consequent. So he miserably failed again.
ChatGPT saying using the Lorentz ether. So I'm not a wizard on any of this. Most of you guys probably know this more than me. ChatGPT saying using the Lorentz ether theory that it's literally 1-to-1 with relativity. It's saying everything could be explained. Everything. It's literally saying it cannot be disproven. The downside is a comms razor, because it's not claiming something that you can't technically detect.
That's what Piezo was saying earlier. That's exactly what Piezo was saying earlier, is that they're equivalent. And they actually they made relativity from ether. That's the thing. They pulled it from that. They didn't just come up with it out of the blue. They altered it, modified it, and then relabeled what already was the case. In terms of components of ether, and they took it in and they rebranded it and changed a few things and put a false model in.
Which is obviously not parsimonious.
But
everything is not parsimonious. It's doing all that rigmarole.
This is obviously with the consideration that Earth's a globe and it's rotating. It's saying that it can't be disproven with those considerations.
Yeah, we get it. Yeah. So yeah, that's everything with all that, like Gio just described, it's antithetical. That's very opposite of parsimonious. That is not the most simplest thing to retroactively re-engineer concepts so you can contrive some ontologically erroneous notion.
Because of a philosophical bias or preference, yeah.
Exactly. It is not an application of Occam's razor at all.
No, it's because the flat Earth doesn't have any explanation for why the pendulum would behave in the same exact way as it would on a rotating globe, and the globe has, because, well, that's...
Gatebreaker just said it does.
Yeah, he ignored that.
The Zanick effect. We just talked.
Wasn't the topic the Foucault pendulum?
Yeah, but that's connected to the Zanick effect and to this whole the component that is related to in terms of the
you obviously weren't listening.
So maybe if someone can get into a debate with the Glober using the Lorentz ether theory, but keep everything else the same, don't argue for non-rotation, don't argue for stationary, that argument may be, it might get somewhere.
But they don't have anything going for them.
Aren't you a Glober now? What's wrong with you?
Because then there's three things being carried in that debate or whatever. It's ether, non-rotation, and stationary. But if it's just ether versus everything else the same, not ether, incorporating Ken's ideas, maybe that debate can go somewhere.
So Gatebreaker before.
Ken who?
Ken Wheeler.
Why is he related to any of this?
The things he brings up about the issues with bumping particles and stuff, and how the ether view can better explain things.
All right. I mean, no, I know he's a guy that talks about these things. I just don't see how he's like a standard for what it should, but I hear you. I mean, if he's like,
he provides insight at best, that's his point.
No, but you're saying how he refers to it and so on. Okay, yeah, I mean, I hear you. But he discusses this similar region of things or area.
So what was it? Gatebreaker, you mentioned before, I think it was going back about 15, 20 minutes or so, but you had an issue with the question of like, how are the bodies, the planets and the stars or whatever, how are they in motion? Is it something like that? You wanted that answered as far as ether physics is concerned?
I was just bringing up like, okay, assuming Earth's stationary and not rotating, but there's planets in the sky that are actually rotating. Not that that means therefore Earth can't be rotating, but that both are happening. Both are happening at the same time, meaning that there's a physics up there in the sky for a planet to rotate. And then I got muted.
Hang on.
I got muted in the middle of trying to clarify, like, does this idea necessitate that planets are no longer, they're not as we know them to be? Like, does that have to be taken into consideration?
Is it
you
the
don't
fact that
know them to be?
What's up, Rob?
Well, Peso like steelman your entire issue to the conclusion.
Yeah, I was just gonna say they only appear to be rotating. You can't actually know that they're rotating bodies up there. Gatebreaker.
I got you. Do you guys think in the conception of a geostationary globe, non-rotating Earth, that one that's being argued for, would that also include and necessitate that NASA's lying in terms of like planets, that they're that they're not going there, their crafts aren't the pictures and videos they've taken that's not accurately.
Yeah, dude. It's all fake as fuck.
They have a helicopter on Mars.
Why are you asking that? You know the answer to that question.
No, I don't have a problem. I'm just trying to accurately have the ideas in my mind of what all is going on.
I already know the answer to that question.
Jeez, guys.
No, but his question I think was like, if it was a stationary globe with all of these balls out there, he's saying, could they still be balls out there? That NASA's not lying about the ball part, like they are going out there, but it's a stationary globe. Is that what you're asking?
Something like that. Yeah, I'm just trying to get all the elements in line of what's actually happening.
That's not an interesting thing. Like it's just a metaphysical truism. Yeah, it's possible. That's a possible world.
Are you more concerned with the rotating of the bodies in the sky, or the fact that they're moving and orbiting around the said sun?
I'm not really concerned with anything. I just want to correctly get all my elements in line. Because in order for it to like work the way I do it, I take multiple things into consideration at once. Okay, if this is this way, how is everything else doing? But what about this? But what about that type thing?
Okay, did we answer it? Because I think I just answered you. Like, it's a possible world.
I'm not throwing this on anyone. I'm not forcing anyone to. This is just how I'm thinking. So that's all.
Okay.
All I got an issue with slightly then. What's up, Gregory?
I'm like he just keeps repeating himself. Like, is it not satisfied? He asked the question. Someone answered it.
All right, let's let Rick go. He's been trying to get in.
What I'm trying to get to is you seem to be sort of astonished at the notion that something else could be causing the orbiting or rotating. That's why I was kind of interested, particularly in that observation that you're keen on. And the issue I've got slightly is the fact that, well, the proposition of the heliocentric model is that these things are orbiting, are rotating, are rocks, and they were set in motion, billions and billions of years ago. And if you ask us, okay, why are they rotating in the sky? We'll say something like an ether field and ether physics or whatever you want to say. And then it seems unreasonable to you to make that declaration. How would that field be rotating? That's ridiculous or something, right? But then when we go investigate in the heliocentric model, I mean, they just kick the can down the road and say that this all was set in motion billions of years ago, and it's just inertia that's playing out. And I just find that to be sort of, why is it so ridiculous if it's ether physics and a field rotating and moving these bodies in the sky, and you're just like basically declaring billions of years and massive rocks? Like,
Okay, so first of all, I was never astonished and I never claimed anything to be ridiculous. I just want to get my cards in line and figure out what's happening. If we're on a ball and it's stationary, what about the physics of this ball makes it stationary, but the physics of those balls up there makes it non-stationary?
How do we know it's not just a mirage that we're witnessing? How do we know How do we stamp validity on the fact that those are planets?
Yeah, it could be, and it could be right. Also, maybe distances are off, and maybe those are just questions I had. I'm not operating in the way you guys think I'm operating.
All right, but isn't it just an assumption as above, so below? Like kind of principle going on here then? Like you just assume that when you look up at the sky, you see terrestrial terra firma up there, and you look down on the ground like it's terra firma, and so this ipso facto must be a ball in the sky. Like, is that what
it's uniformity of nature? It's literally how we go through life.
We're interpreting
with the assumption of uniformity of nature.
We're interpreting too much into his question. He simply asked, "Is this possible?" That's why I just said, "Yeah, it's a truism. It's a trifling question. It's a possible world. What is it? Well, what else is there to say? What else is there to say?"
Yeah, but Jake, I mean, that's not really valid because, like, for example, you could look at another human and be like, they're a woman, therefore I must be a woman, but that may be false. Just because you're in a room of 30 women doesn't mean you're a woman. You know?
No, that's kind of a false equivocation there.
Nope, it's exactly the same.
It's not even equivocation.
No, that would be like
you're saying uniformity. If the moon looks like a little bit like rocks in the Arizona desert or the ground in Nevada, if you've ever, dude, in Nevada looks like the moon, dude. I've driven from like Northern California down through the Nevada way. It is like another world, dude. I literally like the idea of being on like the moon, like in like sci-fi. That's the most any place.
A lot of those movies, they film out there.
Yeah,
a lot of those space type movies they film out there.
I bet,
in the Mojave
dude,
Desert. There's specific places where they do a lot of filming, like Land of the Lost. Planet of the Apes, a lot of the Star Wars stuff.
Because you can. What's wild about it is there's these huge kind of like big like valleys or whatever that you can see, you know, for incredibly long, and there's just no one. There's like no life. You know, you're driving down the road, you might find a little town with like a few houses, but so it's just so barren for so long. It looks like almost like another worldly kind of thing, just because it's the way that it's like that. But my point in bringing it up is that just because the moon surface looks a little bit like things in the desert does not mean that the moon is the same as the rocks in the desert. In the same way, it was not a false equivalent type of thing, because I was saying if you're in a room, of 30 women, it doesn't mean you're a woman. So if the moon looks like a rock, it doesn't mean it's a rock. It's the same thing.
I like the pool hall.
He didn't even say equivalency.
Where all the balls on the pool table are round, therefore the pool table must be round as well.
Yeah.
Yeah.
He said it's equivocation. It's categorically not equivocation. He doesn't know what he's talking about.
Yeah, the pool table thing.
I mean, I was making an analogy. Ultimately, I wasn't trying to match it perfectly, obviously.
Yeah, it's obviously an analogy. It's obviously a true analogy.
Yeah, same thing. If the like balls up there, it doesn't mean we're on a ball. Go ahead, Egypt. Yeah, I think you were cutting out.
Yeah, I think I don't know who it was talking about possible worlds, right?
Funny.
That's a whole different ballgame. Yeah, like the possibility of it existing, like axioms, things like mathematics, like 1 + 1, right? 1 + 1 = 2, regardless of anything. And in a possible world, it would still be 2. 1 + 1.
There's no possible worlds where it would equal non-2.
Exactly. Thank you. You get it.
Yeah.
So I think that
they don't understand these things. They just don't study philosophy. They just ignore it while they get PhDs, which is the acronym for Doctorate of Philosophy.
Well, we're not talking to PhDs. We're talking to the general public, and I think the general public can grasp these ideas.
No, Gregory, it's because they doctored. No, it's because they doctored philosophy. They're doctoring.
Yeah. like again, this is why this is like one historical insight really is very interesting, right? For millennia, this area of knowledge was known as natural philosophy. It's categorically a philosophical issue. Then some anti-theist, antichrist, whatever, decided to relabel this category, just call it science. It's been called science only for the past 200 so odd years. But for millennia, it was known as natural philosophy, and it's obviously quintessential. It's trying to study the fundamental nature of the material things in particular, and the regular function patterns that they operate by, with all sorts of epistemic particular delineated epistemic standards and applications. It's quintessentially philosophical.
Yeah,
They just don't understand this.
Yeah, they actually not just not understand it. They understand it upside down. Like they think of philosophy as being something that is of the mind and is therefore not physical. Therefore, because of this understanding of how science is the end all be all kind of thing. So philosophy is like this second state kind of thing where when it's actually the birthplace of science and whatnot.
Exactly.
Philosophy is the basis of everything that we can think of.
Exactly.
They think of it the other way around, like it
they just have a
comes
caricature of philosophy.
after
They've obviously
science.
been traumatized, right? They've been traumatized by the bad representation of philosophy by god awful philosophers with just yapping their conjecture, right? That's not philosophy. Philosophy is the disciplined attempt to study a worldview.
What up, Dice Low?
Worldview is the object that philosophy is trying to study.
Yeah.
That's it.
Yeah.
To extract the.
So the handle is going towards, it's being pulled towards the other handle. You're not pushing it apart, right? You're pulling it inwards.
You're compressing the handle. Yep.
I thought we moved past this. The push and the pull are
They
just
can't let it go.
descriptive terms for the same pressure.
Well, I wanted to get other opinions. We can't just have three people here. I was just curious what the rest of the people hearing us talk.
Oh no, I mean I've already been in this conversation with you guys a while back, and I was pretty much saying taking somewhat Andy's position that it has to do with direction, right? And the how we relate to that, right? The colloquially understanding that when you're saying you're pulling something, it's often referred to being going towards the individual rather than away from them. So
yeah, regardless if it's a pull or a push, it's always a pressing force that's doing it.
Right.
There's no pulling force. We all agree.
Yes.
Yeah. What did you guys work out with the muscles with Riksky? Is the muscle contracting?
I don't know. That's too complicated because they're always thinking it. They're always using it in the directionality terms, but I would guess it's going to be a press inside there at some point.
Yeah, I heard him say tensile strength. Right. So you got the elasticity of a material and the tensile strength of a material, or the compressibility of it. Just like you've got combustion, right? Outward force, and you've got implosion and inward force. So I think those are all kind of similar examples of what do you want to call that? A dichotomy or something?
I mean, was this trying to solve a greater issue? Because as long as we all agree there's pressure happening, who cares if you want to say a push or a pull?
Well, words have meanings. That's my point, right?
Well, it's super useful to say push or pull. You got to know which way that door is going to swing open, right?
Yeah, that's the whole point.
Well, but now you're just the whole conversation is just null if you agree with that.
Yeah, I mean, I think we're all on the same page.
The main issue I was hearing was equating press to push. That was the only issue of the whole convo, but we figured that out.
Well, I'm just happy that I seem to have got SE to agree that it's the same thing that's happening. That's what I'm happy. Are you happy with? You still happy with that, SE? It's the same thing, just an applied force.
Andy, I posted that thing an hour ago. Yes, I posted it.
Brilliant.
It's a force. One way is pull, one way is push. I posted that an hour ago.
That's it. That's all it is. Fantastic.
Hallelujah. Praise be the Lord. Now we can move on to something whatever. The ground moving upwards. How about that?
Can we talk about the dirty, rotten Jews?
No, I'm just kidding.
No, but I'm curious what Rusty posted. Is there another angle to it, or what was up? Anybody watch that?
What, Rusted Soul? Oh, with their video? No, I didn't watch it yet. I mean, the notion that we're moving, like, I just don't think we're moving. We're definitely not accelerating up. And I mean, I can't say definitely not, but like, bro, if we're accelerating up, do 9.8 meters per second squared times 40 years.
Well, that's the Einsteinian thing.
However old you are. Cole can put in like 87 years or some shit.
Yeah, that's the Einsteinian nonsense. Yeah, that's what they say. That's what Einstein said.
No, this doesn't happen in the Glober model. They can't have the ground going up.
Is it the entire solar system, Andy, that's moving up, or is it just the Earth?
Oh, I think it's a globe, Dicelo. I've gone into the globe. Did a long time ago.
Okay. You're off the moving up thing.
Yeah. But as I said earlier, I can see why Dell reached his conclusion, because he was reaching his conclusion through the instrument.
Oh, he didn't, dude. He didn't. If he went, if he drew his conclusion through the instrument, he would say Earth's accelerating up, not going at a constant speed.
No,
he just did this dance.
As I already said, he was playing with the idea that every object has some kind of resistance to inertia, some sort of resistance of its own. I think that's what he was playing with, that idea. But I see what you're saying, Jeremy. But I still maintain that. I mean, this confuses me to no end, because I can understand for very basic Newton's idea from the laws of motion that if we have an object that's accelerating, well, we're going to need a force. But here we have an accelerating object, and there's no force. There's no force
just because
present.
you can't measure it, just because you can't measure something doesn't mean it's not there.
Well, I mean, the instrument's telling us there's no force.
The instrument's not measuring it. Well, I think it depends on how you have that calibrated, honestly, because you not have it calibrated so it's zero on the ground.
Well, that's exactly the point, though. There's a contrast between the two, right? If it's 9.8 meters per second on the ground, and it's zero in free fall, then you can't suddenly just say that it's been calculated. You know, it's been compromised in some way.
So this is news to you guys when the with the quotation marks. When they say Newton thought the apple fell to the ground, but no. Einstein said it's the ground moving up to meet the apple. It's the first time you guys heard that.
Oh, they say the ground's accelerating up, but they use the word accelerating like not moving, which is very awkward when you get down to it. It's very awkward when you have that combo.
No, they're very specific. It's moving up to meet the apple. And I just posted a thing of your favorite scientist saying the exact same quote. That's what they say. Now, it's ridiculous, of course, but that's what they say.
Yeah, say the floor pushing up, like walls push away from you and shit. They're not saying it's actually moving up. They'll say it's accelerating up, but then they'll say accelerating without moving. They'll say, "Oh no, not up. It's not moving. It's not accelerating up." But it's just as weird. That conversation is very weird to have.
It's not weird. It's stupid. It's doublespeak. Easily debunked.
Yeah.
Which is the apple?
Can I say something to that, because I find this part fascinating. But if you were in a vehicle and you were blindfolded and you're in the back seat, how would you know when the car accelerates forward? How would you know it's accelerating forward?
You get pressed back in a seat.
Yeah, so you feel it in your back, right?
Yeah.
So when you lay down or when you stand up, don't you feel pressure in your feet or your back?
Yep.
That's what we're talking about when we say it accelerates. It's accelerating upward. there is a force pushing you up. When an elevator goes down, when it starts to decelerate, you feel light, right?
Okay, but you guys don't. Well, real quick, you guys don't say that the ground's actually moving up, though, right?
Correct. Yeah, that's where relativity comes.
Yeah, they say it's accelerating without moving.
Yeah.
Well, he might say that, but that's not what they say.
No, that's a good steel man. That's a good steel man right there. I've been through this with Zanick
and it's a double speak. Then it's a double speak. How if the apple is not falling down to the ground and the ground is moving up to move the apple? How is that not moving? How is that not double speak?
Well, I can show you, right? Like, so if there was no wind resistance and you were falling from just falling, you didn't jump out of an airplane, but you're already falling and you don't feel wind resistance and you're blindfolded, you have no other ways to tell you're falling, you would just feel weightless. You'd feel no force from any direction. So you have no acceleration when you're in free fall. That's what relativity is. But when you're on the ground, you feel it forcing up. You're being pushed up from the bottom up, not from the top down. Like in a roller coaster, when you go over and when you're going down, you feel the force in your shoulders. You're accelerating downward. The roller coaster is actually accelerating you downward.
Okay, back to basics. Newton said he got his thing of gravity. He saw an apple fall to the ground. Correct?
Yep.
So did that apple actually fall to the ground?
Yeah.
Now why does Einstein say no? That is wrong. It's the ground that went up to meet the apple. Or are you not aware of that saying?
Because when the apple is in free fall, not when it starts falling, but when it's in free fall, it is not feeling a force. The floor is accelerating upward to it. And so that's what relativity is. So
tell me that's not doublespeak, guys. What he just said right now.
I know it's super difficult, but it's in actuality you can feel it, right? When you feel a car accelerate forward, you feel it in your back. If you're sitting down, you feel it in your back when it accelerates. When you're going down a road with no acceleration, you don't feel anything, right? It's just normal. But when you're standing,
talking about cars. We're not talking about cars. We're talking about an apple falling to the ground.
Yeah. How do you feel acceleration?
We're not talking about how you feel acceleration. We're talking about Newton said the apple fell to the ground, right?
Correct. Yep.
Now you just told me before, no, it's while it's falling, the ground is moving up. Did you not say that?
Yep, because you don't feel.
That's double speak, my friend, and you can't get away with that with bringing a car in.
So stop
one or the other.
You don't need to worry about falling. You just feel the force. Yeah. Sorry. Go ahead.
You want to go, Rob?
Yeah. Sorry, I'm outside. I don't know if you can hear me as well. It's reference frame dependent in that case.
Yep.
Because the apple thinks that it's not moving if it had a thought. It would just see the ground coming towards it.
Yep. Exactly.
Let me ask you this.
Apple's thinking, huh, Rob? Wow, man.
Let me ask you this.
No, you missed the point. It's reference frame dependent.
No, we heard you. Let me ask you a question, Wesley.
Yep.
We got a car. We've been driving it all over town. You know what I'm saying? Car's in fully functional condition. Gas is in it. We're good. You just ran a whole bunch of errands in it, right?
Yep.
And there's a tree planted in the ground on the side of the road, right?
Yep.
All of a sudden, the car hits the tree, right? However that may have happened.
Yep.
In that scenario, did the car move towards the tree or did the tree move towards the car?
If we didn't
a normal
have
tree, we're not in Lord of the Rings, just a normal tree.
No. Okay, so
Use wisely. This is a trick question, by the way.
I know. So yes, we can use all of our other senses. From the perspective of the Earth, the car ran into the tree. from the perspective of the tree, the car ran into, or the tree could have run into it, right? We use multiple other senses to figure out motion on the earth, and we think that when we're standing still, that is actually standing still, but in relativity, motion is undetectable from person to person.
So
you've been conned in.
Hold on,
by
guys.
Einstein.
Hold on, man. Are you telling me you're not 100% certain that the car was the one that moved into the tree in that instance?
No. I am certain from our perspective reference frame that the car did run into the tree.
No, just in reality. Forget reference frames. Just in reality, it moved. It was the car moving 100%, right?
Well, again, movement itself is not detectable outside of any other senses that we could use. Motion is not. But in your example, of course, the car ran into the tree because we would say from our reference frame, the Earth is stationary, the car is actually moving, the wheels are moving, and so we can see it moving along the surface. But this is where
if I was in the tree, that you hit, I could just say I moved into you. That'd be valid, you think?
No, a better example would be two planes traveling toward each other. Two planes are coming at each other. How could you tell without any instruments? How could you tell which plane is traveling? Let's just say they're coming together at 1,000 miles per hour, right? If they were traveling at the same speed, they would be each going 500 miles per hour, right? But how would we ever detect that if we were in either of the planes? We couldn't detect that without looking at the ground, without looking at instruments. If we're just looking at the two planes, we're in one of the planes. How do you know how fast the other plane is going versus you? One could be going 0 and one could be going 1,000. They could both be going 500. There's just no way to tell.
Yeah, but with the tree and the car scenario, we definitely know for sure which one was moving.
Yeah, because we can use other context clues, but in the planes we can't.
Yeah, but okay, just because there's some PhD dudes running around that aren't sure about the tree and the car one. They think it could be either. I'm not joking.
From the tree's perspective, it ran into it. From the chassis perspective, the tree ran into it. But we can see that the wheels are moving, but the chassis can't. The chassis can't tell that the wheels are moving.
How about the apple? The apple tell that it fell to the ground?
So the apple feels no force once it's in free fall.
But it fell to the ground, right? For sure, 100%, right? No, nothing else happened.
From the
it
ground
broke
perspective,
the branch and it fell to the ground, right?
So QE, if you or SE, if you really want to engage with this, I'll do it with you, right? So from the ground's perspective, the apple fell into it because the ground doesn't feel any force until the apple hits it. But from the apple's perspective, once it's in free fall, it doesn't feel any force until the ground hits it. So yes, you have to put it in a different reference frame.
But which one moved into the other one? See, this is another scenario. This is like the car and the tree thing. If you know you're on a globe with a fixed radius, you would know 100% that the ground didn't move up because you got a fixed radius. Things are falling all over the earth. The radius would have to get bigger if the ground moved up to meet the object. You'd have to know in this scenario that it in fact was the object moving down towards the ground, right?
Yep, and this is why we Einstein came up with a curvature and bending of space-time.
Yeah, he broke reality, and some people fall for it.
No, he actually explained reality. It's very complex way to explain it, but if you are free falling, you feel no force. You are weightless. You are not feeling any force, but something is accelerating. You don't feel the acceleration as you fall. If you weigh yourself as you're falling, you weigh 0. So there's
what does that
force.
have to do with what actually happened in reality? Did the apple break up the branch? Bro, don't interrupt me.
Sorry,
please.
I'm sorry.
I don't interrupt you.
Yeah, I'm sorry. You're right.
Okay, no worries. So in reality, we have a tree, right? It grew up, it grew an apple. Now, eventually that twig broke and the apple fell to the ground. Are we absolutely certain of that or not?
From our perspective, yeah, it fell. But again,
in reality, what happened in reality?
Well, if we're really describing reality, we have to think about the bending of space-time.
Oh my god.
That's where you mess up, bro. This guy messed up your brain. You got to realize that. We know.
Okay,
Everybody knows
how come when you free fall you don't feel any acceleration?
We're not talking about that. We're talking about what happens. You're sitting on the grass, a branch breaks and an apple falls. That's reality, bro. There's no other way to explain
the apple doesn't feel force as it falls. The apple is weightless as it falls. It doesn't feel any
but does it fall? Does the apple fall, or did the ground move up to meet the apple?
I agree from you. From our reference frame, yes, the apple falls into the earth. Yes. But now look at it from the
in what other reality can that not be true, bro?
Okay,
Like,
from the apple's reality.
So the apple is not saying, "Wow, I'm falling now." Let's say you were the apple. You wouldn't know that you fell from the tree and hit the floor. You would say, to me it looks like the floor is moving up to hit me. Like,
because you don't feel any force.
Is that what you believe?
You don't feel any force until you hit the floor. You're in free fall until you hit the floor. So that
but you know that you. Yeah, but do you know that you fell from the branch and went down to hit the floor? Like, you're not telling yourself, I wonder if the ground, is moving up to hit me.
Okay, well then answer my question. How would you determine what the speed of the two aircraft that you're in? You're in one of the aircraft. Is the other one going faster toward you, or are you going faster toward it? How would you tell?
But why did you change the scenario now? I'm asking, if you're on the branch, right? You climb the tree and you're falling. Are you at any point in your mind are you saying, the ground is moving up to hit me?
If I woke up as the apple falling down, I would think I'm still. Except for air friction. Except for air friction.
Do you see what you have to do to get away from the reality?
Yeah, but this explains reality, right? Like, on the simplistic, you're exactly right. That's why it took us until the 1900s or whatever it was to figure this out.
No, it took us till then for people to get their minds messed up. Everybody knew from the time of Aristotle that or before that, the Egyptians, the Sumerians, the Chinese, everybody knew when that apple broke from the branch, it fell to the ground. Nobody ever said, I wonder if the ground is moving up to hit the apple. I don't think anybody said that until Einstein came along.
And that's why people still use on Earth, because it makes the most sense to use gravity as the cause and not the bending of and warping of space-time.
You can't pick and choose, though.
What's that?
You can't pick and choose, though.
Yeah, you can, because it simplifies into that. But you're correct. What actually is happening is more complex than we're describing the apple falling from the tree.
Or it's not. I mean, like, why does it have to be?
Okay, I can explain exactly why. When you're in free fall, you feel no force.
That's an explanation. So you have an explanation. That doesn't mean then that's concrete fact.
It's evidence that the Earth is accelerating upward or outward, I would say.
I don't know, man. I just think it's weird that you can use both Newton and Einstein. Like, to me, that just seems like a contradiction.
No, it's
So when you say the Earth's moving upwards, are you saying that the Earth is expanding?
No, I'm saying that there is an acceleration outward from the Earth. That's due to the bending and warping of space-time.
Is it a pseudo acceleration?
I don't know. I haven't looked into that far, but that's the explanation for when you're in free fall, you don't feel any force. But when we're standing on the ground, we feel it. We call it the normal force. But when you're standing on the ground, your feet hurt, right? When you're laying on your back could start to hurt because it's feeling the acceleration upward.
Isn't space and time both conceptual things? They're not real things. They're conceptual.
I don't know.
Space is real, bro. Space is fucking real, dude.
So is
Don't
time.
start with me, Jimmy.
Dude, there is space in between me and you. If not, we'd be touching right now.
You're gonna trigger
Don't
the
get me
flat
all
earthers,
worked
Jeremy.
up over here. Don't make me come through this phone.
Why would you come through the phone? We're already touching each other because there's no space between us, remember?
Yeah. Nice.
Zanick said I got a 2025 Zanick quote, everything touches everything. That was right after the Pazza 2025 quote of everything is in everything. We had some banging quotes this year. Great year for quotes. I wrote all this shit down.
Weren't we supposed to come up with a fallacy of the week or something like that?
Noah gave up on us. I don't know what happened to him.
No, I'm saying I thought we all were supposed to come up with that. I don't know. Maybe I dreamed it.
This guy had one job, man. Can't do nothing with these guys these days.
Bro, we had convex, concave lakes, bro. We had linear lakes, it's insanity. I think we're drifting towards insanity slowly. The more they delve into the pseudo model, the more crazy they become. It's like going down the rabbit hole, you know? And keep in mind, these are people like that came up with this stuff 125 years ago or so. And people are still clinging on to this nonsense. Even though there's new stuff. The new pseudoscientists are coming up with new stuff, disproving the old stuff, but they're still clinging on to it. It's amazing.
You know what's really cool is that clocks, when you speed them up, like on an airplane or in orbit or on a fast jet, that the clocks actually diverge from a clock that's on Earth.
See, that's another nonsense.
It's hard. It's a very, very, very difficult concept, but it's real. We've tested it.
Yeah, but does that mean times? Okay, here's the thing, though. Yeah. We can make clocks be off, and we know that time didn't change. You know what I'm saying? So is that actually different times happening, or is it just the clocks are off now for some various reason?
No, the faster you go toward the speed of light, the slower time ticks for you.
The slower the clock ticks.
Yep. And that's been
proven. Yeah, but you don't know if the clock may not be directly related to time, because we know we can have clocks be off for various reasons.
Yeah, so that we use an atomic clock, which is very, very precise, and then we do the experiment multiple.
Oh, okay. What are atomic clocks? What do atomic clocks use?
They use the oscillation of an atom.
What kind of atom?
I don't know.
A cesium atom. We know about atomic clocks. The point is, what if something's happening that's making the clock be off, and it's just the clock's off? It's not actually time sped up or slowed down for anyone.
Like I mean, like that's what we test for, right? We change the speed and the clock changes. If you had another variable, we could test that it was something else, but that matches with the predictions of relativity.
I know, but are you can see, yes, I agree. I'll just give this to you. You speed the plane up, the clock changes versus the clock on the ground. How do you know it's time and not just the clock?
I like Jeremy's thing when we were talking about this before, when you said something like, what about an hourglass? Would it change how the sand falls through?
Yeah, like saying if we were to do it with an hour, well, me and Napalm came up with this years ago. You know what I'm saying? We were talking about time dilation. Yeah. It's like, yo, I want to see this shit done with an hourglass. Yeah, do it with an hourglass. I know the problem. We know the problem.
Okay, cool. All right.
But seriously though, how do you know if it's the clock or it's time itself, or just the clock?
Not only that, the sun. You use the sun for that. In order for this time dilation to work, when one brother leaves out, right, goes into space and travels, That means the brother at home, in order for him to age, the earth has to be spinning around, or the sun has to be going around faster. You get
Yeah, I
it?
mean, in this time thing,
Nonsense.
yeah, in this time, that's a good point. In this time thing, where the guy on the ground, he's got his clock, and then the guy in the plane, he's got his clock. One of the clocks is speeding up. That means the sun moved faster for them.
Exactly.
No, this time, the way you experience time is different. So the guy on the ground, just our reference frame, stays the same, but if the guy in the rocket, his time slows down the faster he goes.
I know. Is his when it is his so his sun? You're telling me both of their suns are moving at 15 degrees per hour according to both of their clocks?
Well, he's in a rocket, so no.
The sun's not moving 15 degrees per hour for him?
Right, because he's not on the Earth.
But we can't do this in the sunlight? This is a plane flight, right? You can't do the plane thing in the sun?
Right, yeah, and then you get into the time dilation and length contraction, and I don't understand that. So I can't.
And length contraction with the sun?
Yep.
All right, yeah, I know.
But I mean, it's a
Do you think length contraction's ever been measured?
You're way beyond where I am. I'm sure there's somebody else that can explain that here.
We'll get you up to speed. We'll get you up to speed someday.
You're gonna take me to school again. I like this.
I'll take you to school, clean the school, and get you home by dinner.
All right, sweet.
No, but think about it. In order for the brother to get older, the day and night cycle has to speed up for that guy on Earth. There's no way around that. How is the guy going to get older if days and nights don't speed up? Relative to the other brother that's only been gone a year or an hour, and he comes back, and the other brother is like 50 years older. That means the day and night cycle has to speed up. There's no way around that.
All of
that
time
alone
speeds up.
kills
Yeah,
it.
all of time speeds up. It doesn't really matter about the sun. I mean, you could use the sun, but you can use an atomic clock. It speeds up for the slows down for the people on the rocket comparative to the person on the ground.
But think of what you're saying. That means that the day and night cycle on Earth has to speed up. Within an hour, it has to make 50 cycles.
No,
in order for the brother to come back and find his brother.
The person on the Earth, the person on the Earth stays the same. It's the person in the rocket that time slows down for.
No. Both things have to happen, right? Both things have to happen. Time has to slow down for the brother in the rocket ship, and time has to speed up in order for the brother on Earth to get older. Time has to speed up. There's no way around that.
Nope.
What do you mean, no?
He
just wrinkles out of the blue in 1 hour?
No. The Earth stays the same. The time on the Earth stays the same. That is the constant.
So how does he age if it stays the same?
No,
with respect to the brother that only traveled.
The passage of
time.
time.
Are you listening? Are you listening to the scenario here?
You're not listening.
The brother only travels 1 hour, and he comes back. That's 1 hour travel. When he comes back, he finds the brother 50 years older. How did he age if the Earth stays the same?
So you would have to be going at the speed of light, which is not possible to do something like that, or very near, which we don't have the capabilities of doing.
They could get near relative.
Don't let him change the subject, bro. He's changing the subject.
We'll get it.
Answer my question.
Remind me later. Solar sails.
Yeah, but to your point, if you were going at the speed of light, basically infinite time.
No, nothing could go the speed of light. You're changing it's near the speed of light, right? This is what the scenario says.
No, I'm telling you, in an ideal world, if you could go the speed of light, time stops.
You're trying to squirm away from it, bro. We're not talking about the speed of light. We're talking about the scenario when one brother travels near the speed of light, travels for 1 hour, comes back and finds the brother 50 years older. Do you understand that?
Yes. So when you're saying that, then you're talking from the perspective of the brother in the plane, correct?
It's both. The brother on Earth has to age within 1 hour, 50 years.
So okay, so 1 hour for who? 1 hour for the person on Earth, or
for the
1 hour
brother traveling in the near the speed of light?
Correct. So 1 hour in near the speed of light would be that a lot of time on Earth.
So he's
Yeah,
gonna
but
see
it's
the
only
sun.
1 hour. The brother on Earth only sees him 1 hour gone, bro. Don't you understand that?
If the guy was
He sees
watching
his
the
brother
sun,
go, he comes back in an hour. Now he's older. You're not getting it.
No, I am getting it.
if the
The
guy
guy
that
on the
was
screen, the guy on the
real
sorry,
quick,
go ahead.
Wes, real
Yep,
quick,
yep,
real
yep,
quick.
you're good.
If the guy in the rocket, right? His clock only moves an hour, right?
Yep.
This guy's gonna go near the speed of light. How many times does he see the sun go around Earth in that hour?
If he's going around the Earth at the speed of light, he's going to see it millions of times
in an hour. So yeah, that's what I was telling you. It's not moving 15 degrees an hour for everyone anymore.
Correct. If he's in orbit, if he's in orbit around the Earth, going near the speed of light, he's going to see the sun millions of times.
No, not hold on, not going just straight out and straight back. Forget though, because that'll mess up your how many.
Okay, but
straight out and straight back. He's always looking at Earth though, watching how many times the sun goes around.
No, the Earth rotates a million times if he goes straight out from the Earth.
And what does the brother on Earth see?
Oh yeah, you wouldn't see the sun. Hold on, no. How many times do you see Earth go around the sun? If you just went straight out.
So if the brother on Earth aged 50 years, you said?
No, dude, the guy. Hold on, the guy on the rocket. He's 1 hour. He's looking back, right? He can see the whole Earth and shit now, and the sun. How many times does he see the Earth go around the sun?
If the brother on the Earth goes 50 years older, it would be 50 times.
And the brother on Earth?
And then he's gonna see it.
And what does the brother on Earth see?
The brother on each of them, for each of them, they experience time the same. So the brother on Earth feels 50 years. The brother on the plane feels an hour.
You're not getting it, bro. You're not getting it.
No, that's exactly. If you don't understand it, it's fine. But that's what
No,
actually.
you don't understand it, bro. You don't understand it.
The brother on the Earth feels 50 years goes by. The brother on the plane feels 1 year go by because he's traveling at the speed of light.
Yo, this is how you leapfrog through time like a vampire.
It's Planet of the Apes, man. They got it right.
No, you've been bamboozled, bro. You're in the Wizard of Oz. You just don't understand. You don't understand the whole.
Then explain to me why clocks slow down faster they go.
They don't, bro. It's all in your mind. This is what I'm trying to give you an example. In 1 hour, the Earth, the sun has to go around 50 times in 1 hour, which is physically impossible, but you're just not understanding it.
No, it's not. If you're going at the speed of light, it's not.
But see, there you go. You just still don't get the paradigm. You don't get the whole thing of what this time dilation is.
So they're lying to us that when a clock speeds up on a plane or a satellite, that they're just lying to us. That's
well,
not
those
real.
tests had varying results. I just gave it to you earlier for the sake of argument, but
no, I know
those results had varying. There's varying results with those.
So they're lying to us about clocks on satellites that they have to account for the speed that they're going at for relativity. They're lying to us.
I wouldn't say they're
first
lying.
of all, the guy who fixed the GPS system also wrote a book called Escaping Einstein. So there's that. But
people can go crazy. You agree with me, right?
What was I gonna say? No, he didn't go crazy, bro. Hold on, I was gonna say something out of the other.
There's a Harvard scientist that thinks that aliens are real because of a comet, so I would disagree.
Well, I'm not saying nobody goes crazy, but
you know what else this fantasy thing says? If you travel at the speed of light, you slow down time. I imagine you believe that as well?
That's what we just literally talked about.
Was it something about solar sails, Jeremy?
Yeah. We could theoretically get up to relativistic speeds with solar sails. In fact, there's a huge conundrum with that.
Yep.
Because right now the idea is if we want to move in space, we have to eject mass, right? But they have this thing called a solar sail, which you don't have to eject mass for. You know what I'm saying? Giant sail catches the sunlight. But that leads me to another thing. That leads me to another thing, though. You could get a nuclear powered spaceship like we do aircraft carriers and submarines and whatnot.
Yep.
And you could just shoot light at your own solar sail and you wouldn't even need a star.
Well, for every action, there's a reaction. So that's like if you're on
Let me stop you right there. Let me stop you right there then. Scratch the solar sail. Let's just shoot light out the back.
Yep. But light is massless. So, well, that's a cool thing about the solar sail. I don't know how
if you're saying that I can't shoot the light into the solar sail because of this equal and opposite, I hear you. Okay, fine. Then we're just shooting it out the back.
Yep. No, you're right. I don't know how a solar sail works. So that's
nobody does. Nobody does. Space is fake and gay, dude.
Nice.
Now you guys
say that.
To La La Land.
Say that. None of this shit's real, dude. No, nobody knows how it works. Don Pettit don't know how to do a fucking emergency procedure on ISS. Nobody knows how this shit works.
Oh my gosh, seriously.
Bro,
hey, Jerry.
One brother could age slower or faster than the other. You're already gone. You're already out. You're out to lunch already. Sorry, man.
Hey, real quick, guys. I just popped in to say one thing. I still don't have a voice, but just so Wesley knows, and he's not going to look into it probably, but just for the context of the conversation, this all comes from the Michelson-Morley experiment where they were getting a different speed of light in one direction rather than another, the preferred direction of light. So they had to keep the constant of the speed of light, otherwise everything's messed up with like light years, and they had to have that as a constant. So instead of admitting that there was a variance in the speed of light, they had to make something else the variable. So they made time the variable, and that's why they had to go off on all these other, things about atomic clocks and everything else and reifying their model to keep the constant of the speed of light, which is the variable. So then they just switched it out and then had to say there was a Lorentz contraction and the device that was measuring it contracted and all these other crazy things that aren't true at all. Just for context.
Yeah, no,
and another thing related to the aging of the brothers, right? It's not just in the speed of light, right? Gravity, they say as well, right? So in other words, if you have a twin brother living all his life on the basement floor and another brother living on the 85th floor, do you know that they say one brother ages faster than the other?
Yeah. Do you know by how much?
Another nonsense.
No. Do you know by how much?
It doesn't matter by how much. By a very little amount.
An undetectable amount. You would never know by their telomeres or something.
And do you know why it's different? Why would they?
They say that due to gravitational. Well, they say that there's two different types of time dilation. They say one's due to gravity, and other one's due to, how fast.
Exactly.
One's
Both
GR, one's
nonsense.
SR.
Well, okay, yeah, maybe I don't know the gravitational one, but the guy on the 85th floor is traveling faster than the guy in the basement.
Not because of travel, because of gravity. That's what I'm trying to tell you. That's part of the nonsense of traveling at the speed of light. One guy.
Well, no, what I'm telling you, Essie,
there's two aspects to it, bro. But you keep
what I'm telling you,
interrupting me
Essie,
when I talk.
is the brother at the top of the building versus the brother at the bottom. The brother at the top is traveling faster, so he would age slower than the brother at the bottom.
Yeah, but what I'm trying to tell you is that thing has two things to it. One is speed, and the other one is gravity.
Yep. Because mass warps space-time. Yeah, I agree with you.
You could believe what you want, bro. I mean,
I know.
It's so
what
weird
I believe.
that just normally comes out of your the warping of space. Like, dude, how do you not know that sounds weird?
No, I agree completely it sounds weird. When I first took it in physics, I was like, nah, dude, this is crazy. And then we started to do experiments, we started doing the math, and it works out.
And they indoctrinated you.
Yeah, I know you would. I think that, but we do actually do experiments showing this, and we read white papers about the airplane experiment. That can be replicated and has been done many times. So
Did you read the papers though? Because like I said, they had varying results. Like you just get fed this. You just get spoon fed the
you're right.
generic one.
You're right. I mean, it wasn't bang on, and nothing in our world is bang on.
Yeah, we get it.
Yeah, but it is.
You know how much they say the clocks were off?
It is fairly accurate because satellites work in space, giving us accurate times.
Wesley, do you know how much they say the clocks were off?
No, I don't remember.
A few billionths of a second.
If you had another metric that you could measure this by, I might go for it. I might not, but if there was something other than a cesium atom oscillation procedure that could measure this, like you know what I'm saying?
Yep.
And in order to believe this, you have to believe that they took time and space, the thing that's between me and you, and meshed it together. Like, surely you don't believe that, or do you?
Say that one more time. I was reading something.
Do you believe that they took time, what a clock reads, and the space between me and you, and they meshed it together and they made the fabric of space-time?
Who made it?
Einstein.
He didn't make it. It's always
Yeah,
been.
Yes, he did. It's conceptual.
So you believe it? Wow.
No, Einstein made that shit up, bro. What do you mean?
That's what I mean by conceptual, bro.
You know what? It would be really weird. Einstein said, "Yeah, I made space time. I made the fabric of our reality." He never said that. What are you talking about?
Oh my god!
Well, he actually stole it from somebody, but yeah, somebody came up with it. You think what they discovered this? Is that what you're saying?
Nobody like found it. There's no nobody ever found this shit.
Like they were walking down the street one day and they said, "Holy shit! I just hit space time."
Space time! Oh my god!
It's the most accurate description of our reality. If you got something better than that, go for it. But until you do, it's the most accurate description.
You're just saying talking points.
Okay, Essie. What's a better description? What's a better description of our reality than that?
Mond actually made a better prediction recently when it came to the rotation of a galaxy. Like Mond made a prediction, and GR Dark Matter made a prediction, and Mond got it closer. So modified Newtonian dynamics. Modified Newtonian dynamics.
Oh, okay. And who is that? Is that somebody here, or is that just a science group?
Just a science thing.
Okay. Do they believe the Earth is flat?
It doesn't matter.
No, they're talking about the rotations of galaxies.
Okay.
I doubt it.
Yeah, no, I have no idea who Mond is or what Mond is. So
it's called modified Newtonian dynamics. It's like a idea or something. They're trying to save They're trying to save Newton, bro. People want to save Newton. GR destroyed Newton. They want to bring back Newton.
Well, Newton is correct when you're not dealing at relativistic speeds. Einstein did. I mean, I know that's a talking point, but Einstein didn't destroy Newton. He refined it.
No, but let me explain. Let me explain why it destroyed it, though. Right?
Okay.
Physics is like what's happening in physical reality, right?
This is a description, yeah.
Yeah, it's describing what is actually happening in physical reality.
Yep.
So when you drop something, you have mass accelerating, right? That's just in reality. You drop something one way or the other, mass is accelerating. With F equals ma, you have a force there. With GR, there is no force there. So those are absolutely incompatible physically with each other.
Yep.
Yeah, that's what I'm saying. GR destroyed Newton. His first law got wrecked too. The first law is not safe.
Well, yeah, but Einstein always knew about frames of reference. From our frames of reference on the surface of the Earth, things are accelerating toward us. but that's not actually what's happening.
I know, but there can't be a force and not a force at the same time. That'd be a law of non-contradiction violation.
I
So
know,
we know
but
one of them has to be wrong, right? Like one of them has to be wrong.
Yeah, and what's demonstrably wrong is that things accelerate toward the Earth. That's demonstrably wrong, but we can model it that way.
No, you have to have that on a globe, dude. You can't have the ground moving up on a globe. You have to have the object moving down. Otherwise, you would have Otherwise, you would get a bigger radius.
Yes, I understand this.
If you're at the North Pole, if you're at the North Pole, I'm at the South Pole. We got people all over the equator. People are dropping stuff all over the place, right? Just all over the place.
Yeah.
Now, if the Earth moves up at all, right, the radius would change. So it has to be the objects moving down. We know it. If you're on a globe, it has to be that way.
Or space-time is curving.
That doesn't help get you out of something's accelerating towards another thing. So one of them has to be actually moving in reality.
And space-time.
Yeah, bro, you can't just say,
space-time. It's not like a get out of jail free card or something.
It's not. But I don't fully understand it, so I'm not going to go much further than that. But I can demonstrably show you, and I have, that something in free fall is not accelerating toward the Earth, because it's.
You know why you don't understand it, bro? You know why you don't understand it? Because it's nonsense, bro. That's why you don't understand.
You guys agree that force equals mass times acceleration? Do you agree with that at all? Maybe you don't. Force equals m times a. Do you guys agree with that?
I think F equals ma is true. Yes, I think GR is the wrong one.
Okay, then how do we have weight on the Earth if we're not accelerating?
If we're not accelerating?
Yep. Force equals ma. We all weigh something. Weight is a force. So weight is equal to m times a. Mass times acceleration.
Weight's not a force. A force is required to counterweight. So weight can't be a force.
Weight is a force, but that's okay.
I mean, I know you'd like to think that, but unfortunately.
Well, then why does it take force to walk?
Movement is not a weight.
A force of what? I mean, you just like to throw this term force out there, but unless you can identify a force of what, by what, and to what, I mean, you're just literally throwing a label out there.
When you're standing, you feel a force on your feet. When you're laying on your back, you feel a force on your back. I mean, that is force.
I understand. I understand what you're calling it. I don't deny that I feel that pressure.
Okay, so what is that pressure? What is that pressure?
Yeah, I mean, we can refer to it as weight, but to say weight's a force is, I think wrong.
Your material resisting another material is what it is. And when you move something, if I take something to move it and put a scale on there, you're telling me I can get the weight of it? Because I'm moving it?
Say that one more time.
And the observations are not matching. How do you take away refraction when you do the observation? Are you claiming there's no refraction when they do the observation?
No,
so the star is getting occluded, right?
Yeah.
The star is getting obstructed by the mountaintop, right?
Yeah, but the light coming from the star is refracted, yes? And the light from the mountain is refracted.
You cannot refract. You cannot block a light with a refracted object. That's ridiculous.
Yeah, but what happens to that?
You're blocking the light with a physical object. You're blocking the light with a physical object. I posted a picture.
Listen, guys, listen.
Wait a second. Can you hear me out?
Right? Yeah, just give me 1 second. Let me just. I will. I'm going to go to. I'm sorry. I apologize. Okay, go ahead. Go ahead. Actually, I'm sorry. I did step on you. Go ahead.
I just wanted to say. I posted a picture in the chat. There you see one straight line, and you see the basically refracted path of the starlight. So just assume the star is at that position. So the point, we are basically seeing the millisecond before the star is occluded. At that point, the actual mountain tip is in the path of the actual path of light, and that actual path of light is curving downwards. And at that point, if you switch off refraction, you would have it way lower behind the mountain at that point. And if you think that the stars in stellarium, if you switch off refraction, are at their actual position, then we have no discussion. This is absolutely true, and that shows, and wait a second, and that shows that we are living on a ball. Because if the stars in stellarium are at their actual position, there must be a GP of the southern poles, there must be a GP of the northern poles, there must be an equator where all the stars have straight lines, and every 1 degree on the Earth, or every 60 nautical miles, all the stars go physically 1 degree down. So if you claim that, then a flat Earth is completely out of discussion. And that's the problem with the celestial theodolite.
Have you seen it? Have you seen their
Yes, I've seen it. They are using a celestial sphere, on the one hand, claiming that all the stars are seen at their celestial sphere at their physical position.
That's incorrect.
And then claiming that they are not because we are living on a flat Earth.
That is not true. So what the deal is they're making an observation, and they're simply just recording the time that the star gets occluded by the mountain. And that happens. We all agree that that's an actual observation that can be made. Okay? Now, if you put yourself on a flat Earth, you can turn off refraction, it goes to the true position, and it's checking whether or not stellarium is being accurate or not. And stellarium doesn't know where the fuck we're at. They don't care. It's just from the mountaintop to where that star is, and that's the angle you have. And it goes, well, wouldn't you know, on a planar trig, using planar trig, it matches flat Earth observations every single time. And I don't care what anybody says. If they really look into it, there is no debate here. There is no.
Okay, so let me ask you a clear.
Nobody's debunked it.
Can I ask you a clear?
This is all.
Yeah.
They've been transparent about everything.
Clarifying
they have all their
question,
data out there. So yeah, go ahead.
Yeah. Okay. So you use stellarium without refraction. You do the observation where refraction is part of your observation, and then you compare the two.
You do the observation, then you put yourself on the mountain where what is occluding the star. And when you put yourself on the mountain, you turn off refraction, you get the true position of the star, and wouldn't you know it, the angle from the star to the mountaintop matches the angle from the observation to the top of the mountain. So that's planar trig, bro. If you're on a
what I'm saying is, hang on. You use stellarium. You take away refraction. Okay,
correct.
That's what you do. Yes, when you do the observation in reality.
Well,
refraction
where else would I be doing my observation?
No, but hang on, let me finish. You can't, when you do the observation in reality, refraction is a part of that observation, yes?
Dude, if we're doing an observation, I would hope it'd be in reality, but what was the rest of that? That kind of threw me off. So if you do
when you do the observation in reality, refraction is part of that observation.
Dude, nobody is saying that refraction doesn't exist. Nobody's saying that refraction is wrong. Nobody's saying there is no refraction. All that they're saying is that there is a snapshot that's getting taken when the star gets occluded, and guess what? It matches flat Earth every single time. And if you want to go to their data, they have their data.
You're missing the point. Let him finish.
Yeah, the problem here is you use stellarium without refraction. Then you do the observation with refraction, and then you claim by using stellarium without refraction, compare it to the observation with refraction, then it's sort of conform to a flat Earth. You can't do that. If you're going to compare stellarium to the real observation, you need to have refraction in stellarium as well, don't you?
Okay, so no. So because you're making the observation, because you're making the observation itself, right? The observation is getting made. We all agreed about that. So there is no dispute on whether or not an observation is being made. So in that observation that they're recording, and this is all they're doing, right? They're not guessing anything. They're not doing any of that. They're just simply taking the time that this mountain peak gets occluded by the star. They do planar trig, and every time they can pick out the distance away they were from the observation, and you can use the flat Earth trig to figure all the rest of that shit out. and it's in their books, it's in their data. Like,
yeah,
dude, they're not trying to hide
refraction.
anything. They have everything
when
written
they
down.
do that, do they include refraction or do they not include refraction?
Well, there's no really need to do it. So what? Terrestrial refraction, and then what? You have the astronomical refraction.
What
like
he's
two
asking you is,
separate.
does refraction exist for the observation? That's what he's asking you. If it's occluded, is refraction part of that occluded observation? That's all he's asking.
I would say no.
The position of the star and the mountain peak, when you do the observation, will be affected by refraction. You agree?
Well, you can say that, but there's no evidence that refracted objects can block light. There's no evidence.
That was not my question. It was a simple yes or no question. You do agree that when you observe the mountain and the star,
when you're
what you see is affected by refraction, yes?
Now, when you mean refraction, so when you say affected by refraction, I'm just guessing that means that you would think that a refracted object would actually block the light.
No, that's not my question. It's a fucking simple question. When they do those observations, is the mountain and the star affected by refraction? It's a simple yes or no question. Yes, it is. Yes.
No, I would say no because
now there's no refraction. Okay.
You're not making
suddenly there's no refraction in the atmosphere.
Can you stop for a second?
Yeah, from Dr. Hand's yard to the mountain peak is a complete vacuum chamber, is it?
Yeah, it seems like it.
The answer is yes, it's affected by refraction. He's not asking you to confirm to what degree. He's just asking you, hey, is reality reality? And you're saying, no, it's not.
Dude, what the fuck? You got that out of that? Really? Come on.
Yeah, exactly. What he even stated much better than me. What in the observation.
I'm on to you.
Well, when they do the observation, it's what they see is refracted by the atmosphere. Yes or no? It's quite simple.
Are you every time you look out into the horizon, there is going to be refraction, but at the same time, you got to understand they're not going out to measure refraction. That's not the point. They're not going out to do that. They're going out to simply record a data point. And it's a super strong one because you're using
you do an observation. Yeah, but let me see if I get this correct. They do an observation which is refracted. Then they compare that to stellarium, where they take away refraction. Compare the data from the refracted observation to stellarium without refraction, and use that as an argument.
And all that on a model that is absolutely the globe model, on a map that is a globe map with a distance formula, the Haversine formula that calculates two different points on that globe map.
What map have you ever came across that said this is a globe map? Get the fuck out of here with that. Dude.
Every map that is out there, every map, Google Earth, Google Maps, all these maps are globe maps. That's why the distance in the south. That's why the distance in the south are okay. Are you interrupting, or you want to answer my get my
what
your
shape
question
or map?
answered?
Let's just hurry this along because my question isn't going to stop you. How much? What is the shape of maps?
Google Maps, Google Earth, all these maps are projections of the globe. The distances of the latitude lines are getting, of the longitude lines are getting closer in the south. You have all that is a globe. And the distances on these coordinate systems are calculated by the Haversine formula, which is a globe formula that shows you a section of a circle to calculate a distance, and they are using that formula in their system. So they use a globe model of the star, they use a globe map, and they use globe formulas, and then switch off one calculation that represents correctly reality and says, see, it's flat.
Well, they actually remove the atmosphere essentially, and so it's indicative of an ideal situation.
Now listen, there is something you can do in Stellarium, which is called get the true position. They wouldn't have that setting in Stellarium if it didn't mean anything. So of course it means something.
Well, what he's saying too,
it shows the true position of the star, but this is not what you see through the atmosphere. And again, if you accept these true position as being a true position and not just an optical phenomenon, then that would even prove the globe.
No, see, that's what I'm saying is that what has been found out is that the whole reason there's a globe that even exists is because of that. It's because they're distorting what we don't see. Like that's exactly
so you're
what's happening.
claiming the stars
what
are
the
not at the
celestial
true
theodolite
position in
does.
Stellarium.
What the celestial theodolite does is it gives you two separate data points, one for the globe, one for the flat, and it matches flat every single time. And you guys hate it.
Again, the question: Are you either stating that the stars in Stellarium are shown at their true position or true direction, or are you stating that these directions in Stellarium are happening to an unknown optical effect?
What I'm saying is that when a star gets occluded, right? So there's a timing.
I'm not there yet.
There's a timing
first
issue
at your understanding of Stellarium.
Angle, that's what I'm trying to get to. Angle means time, right? So the star that you're looking at, the angle means time. So the star that you're looking at, oh my God, the star that you're looking at gets occluded by the mountain. We all agreed that observation is in fact happening.
Yes. But not angle means time. Okay, go ahead.
So the null hypothesis is the Earth is not flat. So they go in with the hypothesis that the Earth isn't flat. And the reason they're able to do that is because they take one thing that actually happens, it's a true observation that can prove it once and for all, whether we live on a flat or if the sky matches flat or if it matches globe. And so this guy comes out of nowhere with this awesome way to do it, and you guys hate it.
I don't hate it. I think it's kind of funny. Can I come back to my question? Do you think that the stars in Stellarium, if you switch off refraction, are at their true position or true direction? Or don't you think that?
I would think that whenever they take the time that the star gets occluded and they put themselves on the mountain where that's doing the occluding and the angle matches when they turn off refraction, I find that to be very, very interesting.
That wasn't his question, though. Why won't you answer? I want you answering his question.
Asked, are the stars at their true direction, or are the stars affected by some optical phenomenon to be there on our sky?
Optical phenomenon.
If I look, for example, from my position to Polaris, and I would switch off refraction. So from my position, for example, Polaris is roughly 45 degrees.
I'm not talking about Polaris.
Wait a second.
This is about celestial theodolite.
Hello. Yeah, I know. You can also occlude Polaris with celestial theodolite, and the good thing is you don't need a specific time for that. So, at my position,
I need you to be the question police.
Let him draw the analogy.
Answering the question police.
Yeah, I tried to ask the question so that you understand, because I asked it already 2 times and you always did not answer. And I assume you didn't correctly understand my questions. Therefore, I try to rephrase it. So when I look to...
Can I try to steel man? Can I steel man? See if I got this right? Okay, so you're saying that
I'm not saying, I'm asking you.
The star in the sky is that that refraction is where we're seeing it, right? So we're not actually seeing it in its actual position.
I'm asking you if you switch off refraction and ignore refraction. Ignore refraction. Ignore that we are have an atmosphere.
You're on my side
ignore
now.
it completely. Just for a second. Wait a second. I'm not there yet. Wait a second. Without refraction, in Stellarium, does Stellarium show the actual direction where the star is relative to our current position?
Is there is there an angle that's applied to where you're making the observation? So like angle to a star, right? That would be time. The angle would match time.
Okay. Ignore, please, the time effect. That's why I said if you look on Stellarium on Polaris and I look in reality on Polaris, I can compare these two things. They appear at the same direction. If I put my position in Stellarium, and it doesn't matter if I switch on or off refraction, because Polaris is not affected by refraction in Stellarium, and also in real world, basically not. So if I look to Polaris, it's 45 degrees up in the sky, independently of time. Same happens in Stellarium as well, independently of time, 45 degrees up in the sky. Is that the actual position of Polaris? Is Polaris in that direction? Yes or no, in your opinion?
To move this along, I'll say yes. Okay, whatever. Go ahead.
Okay,
this
so
has
if
nothing to do with
Polaris,
what I
if
was
the
talking
stars
about.
in Stellarium without refraction are at their actual location,
I don't know that for
then
sure.
I can
No.
use
I do not
these.
know. I do not know if those stars are in the positions that they say they are. The only thing I can go off of is the angle that it gives me when the star gets occluded. That's all I got.
Okay,
As far as like true position or any of that, I
are
don't
not
know the true
actually at that
position. I'm not. I didn't make the stars, so I'm never going to know the true position of anything that's in the sky. I don't think.
If you
But you
don't
trust
know
your
if the
observation.
stars at their actual position at that point, from the point of where you are looking, and they may appear on a different position on a different point, the whole moving the observer point from you to the mountain doesn't work, because we know for a fact if the Earth would be flat, then the
It's
stars
like you're
would
not.
not.
It's
Wait
like
a
you're not
second. Wait a
either
second.
you're doing this
Please
on
don't
purpose,
interrupt. Come on.
or you're really not really getting it.
If
Like
the
this
Earth
is
is
pointless.
flat, then the stars cannot be at their actual position, because if we move to a different point, the stars change a certain amount of degrees, and that would not follow the curved Earth. So because we know if we are on a flat Earth, then the stars are not at their actual position, we cannot then use the actual position of the stars to prove flat
Did you
Earth.
know that? Did you know that you can put Stellarium into a planar mode? Did you know that Stellarium has that function?
Yeah, it doesn't change the situation. They are using the global mode, the celestial sphere mode, and
No,
they
but did you know
claim
that?
the stars and
Did
they
you know
claim
that
the stars to be at their actual ground position, and then they
Did you
use
know?
it to demonstrate flat Earth. The whole concept doesn't work out, because either you say the celestial sphere is a completely distorted image of something that is on top of our Earth. And if we look south in the southern hemisphere, we are actually looking into different directions or the same directions, but there is some kind of these weird Gauss curve, whatever torus field or so that makes the sky. This is one option. Or
You're
you
stuck
say,
on
no, this is
Stellarium.
actually
You
what
don't
we
get it.
see, and we
You
use
don't
the
get it.
sky to determine the shape of the Earth. Then you have to go the whole way.
So they
Go
need
ahead.
to do it different way. So they can do it. They just need to do it differently. Is that what you're saying?
You can definitely use the sky to determine the shape of the Earth. That is the claim of the
Well,
globe
how would
Earth.
you do
And
it?
that is why the flat earthers for
How would
years
you do
and
it?
years say, nah, you cannot look up to use the shape of the sky, of the
How
Earth.
would you do
That
it?
is, I think, also original Eric Dubay claim. And now flat earthers are not only using the sky to define the shape of the Earth, they are also using global mass for that.
How would you do it?
Just measure angles to stars. Super easy.
But you have to leave refraction on there, right?
No, I don't care
Well, that's
about
where.
refraction. You just have to take stars that are not very close to the horizon,
Well,
or
you
you
better
don't have
care
to
about
be super
refraction
accurate.
because the time the star gets occluded on a globe is a totally different time, bro. And it's a different place.
That's not true. Only if you measure with refraction and then switch off
You're
refraction to
telling
make
me
a
that I don't think it's
calculation.
true? Dude, I've been on this since day fucking one. Don't tell me that I don't know this shit. I know the shit.
You know what's even easier? What's even easier is to pick one star and track it for one night and then fly to New Zealand and then pick another star and track that for one night. And then you can see that they go in different directions and you know that you're not on a flat Earth.
Flip that bill.
Yeah.
How much you think that would cost?
Probably $2,500.
2,500. Get the fuck out of here. That'd be like 30 grand.
To fly to New Zealand? How much is a ticket from the United States to New Zealand? I would guess it's like.
That's actually a good question.
Probably like $900 on off season. I mean, I wouldn't think it's insane.
3,500 maybe. 3,500 to New Zealand. You'd probably have to rent the planes.
Or you could befriend somebody like that you trust is actually where they say they are, and you could have them do an observation, and you could watch it live. I mean,
so what would you need to see to get you off the globe?
I would need to see non-circumpolar stars in opposite direction. That'd be an easy one, but I've never seen that. I might have said that wrong. Circumpolar stars, they're like impossible when there's two poles, right? There can't be two poles on a flat Earth.
I got you.
That would actually be a really weird phenomenon. If there were two poles and they were both spinning in the same direction, then I would scratch my head.
Well, what if like the Earth was actually flat and motionless? What would you do then?
Then I would admire the fact that there's only one pole and there's only one direction that the stars rotate, and then I would go from there.
I think New Perspective has that two-pole theory. I watched like 30 minutes of the first video that came out on that. Have you seen that? New Perspective video he put out, two poles.
Yes, and he completely cannot explain any flight paths there, except of those that are close to the center.
I'm sure, dude. Come on, Dave, get on here, brother. You gotta defend yourself. He'll find it. He'll come on here. And I'm sure he'll answer any of your questions. Nobody's dodging nothing. Like nothing's happening.
It seems like maybe you don't understand how two poles would work. Is that right?
Dude, like it's hard for me to like think about right now, but I can kind of see it. If that makes sense. Like it's a possibility in my mind anyway, because I just know that it's flat and motionless, but the two pole thing does kind of answer some questions. I'm never going to be 100% on anything because I just really ain't going to know. I'm just basically
Do you acknowledge that the two poles work precisely to a globe model? Do you at least acknowledge that?
Dude, I've been around for a minute.
So the answer is yes or no?
Yeah, dude, I know how the globe is supposed to be. I know how they say it works. I get it. Like, okay, you can take all these things that I witness and then tell me that you only witness it because you're on a ball now. And then I'm just supposed to be like, okay, then you know better than me. Because you taught me this.
All I asked was, do you acknowledge that it works exactly like the globe says it should?
Yeah.
Okay.
I don't think it does. I was asking a question the other day. Yeah, let's say during equinox, if you're at the equator and let's say you're on that dual pole model, it's on the west or the east side of that map, and you have a compass on the equinox, there should be like a 90-degree angles between the north and east. But if you go by that map, that angle will be less than 90, way less than 90. Because the
Are you
compass
talking about the
has
star trails? Or are you talking about something
No,
different?
equinox, when the sun is directly in the east for everyone. So if you're in west of the U.S. or east of the Asian, and the compass will point towards north, you will not have a 90-degree angle between north and the position of the sun.
I got a question.
No, I was talking about but Stefan Mudd, I was asking him if he acknowledges that the star trails behave exactly like the globe model says. Were you talking about that, or were you doing a different?
No, it's a different point,
okay.
which I have a problem. Yeah, because I tried to look into this claimed dual pole, and I see quite a few problems there.
Have you guys seen the video of the pilot? He took like a time lapse of him flying somewhere far north to somewhere far south. But the whole time the stars were in the window, right? And they're supposed to like move a certain degree if you're on a globe. And they just stay right there. Like it's crazy, but it totally does not match what a globe says should be happening. Like it's very interesting. That was a long time ago.
Did you see the video? Did you see the video that corrected that one and explained how it worked on a globe? And why
the bullshit
it doesn't work?
explanations? The bullshit explanations? Oh yeah, I don't see that shit.
So now it's okay. So since it doesn't conform to your belief, then it's suddenly just bullshit.
It's not what I said. I didn't say because it doesn't conform to my belief. That's not why I am making the decision I made. I'm making the decision off of the evidence that was presented to me, and I was able to discern with that evidence that the globe model predicts one thing and it's not happening. That's all I'm pointing out. Now, as far as anything else goes on, if somebody can explain it, sure, you can explain away or whatever, and I'll listen to it and I'll take it into it.
It does match the globe.
Now, there's people that say that that's incorrect. I don't know what else to tell you, bro. Like,
yeah, there's plenty of people who's been looking into this and doing it correctly, and it matches the globe. So which is correct?
What matches a globe? What video are you talking about that matches a globe?
The video of the stars in through the window of that plane.
Presumably the same thing that you're talking about.
Yeah.
Well, okay. So are you saying that when he was moving from south to north, that the stars behaved the way that the globe said that they would behave? Is that what you're saying?
Yeah, and by the way, he moved from north to south, didn't he?
It could have been either one. I'm not sure.
Yeah, it did.
Do either of you guys know the maker of the video or what to?
I think it was Plain Truth. Plain Truth, I believe. I could be wrong though.
I can't remember who did the video going through it and sort of explained how it matches the globe as well.
The pilot isn't a flat earther. Like this guy is he just recorded his flight, and that's what everybody witnessed. And he wasn't part of it, or he had nothing to do with like trying to make it. He didn't have anything in the game. You know what I'm saying? The pilot didn't care either way. So there was people that were making claims that the pilot was in on it and that the video was faked and all this stuff. And it's like, okay, whatever. That's fine. People can believe that. People can believe whatever they want to believe. I'm just saying, a little shady, a little weird. And that's just more evidence that we live on a flat motionless plane. Could be wrong though.
Why is that evidence? Because when people go through it and bring in all the effects, I mean, rotation of the Earth or the movement of the star,
no, I just go off of
the path of the plane and so on and so forth, it matches the globe. So which one is it? Which one is correct?
Self-evident. I just go off of what is self-evident to me. And there's nothing in my life any evidence in my life to where I was like, oh man, I'm not actually seeing the sky moving. I'm actually the one that's moving. And oh man, I figured it out. No, ever since I was a kid, I knew that I wasn't spinning and that the stars weren't burning balls of gas over billions of miles away or whatever.
How do you know this?
This is my life, bro. This is how I grew up.
No, you said you knew. How do you know this? What do you base your beliefs on?
What age were you when you had a self-evident moment that made you realize that you live on a globe? You tell me what age you were in what you were doing? Because I'm sure that had to have been a wonderful, magnificent moment.
No. I think it was
when
first
you were
time
taught that that was the
13,
case.
14, 13, 14 years when I got my first telescope.
When
And
they
then
taught
later
you.
on,
Yeah.
and later
When they
on
told you all that.
when we did the measurements of the elevation angle to Polaris from 62 to 69 degrees,
But is
so
that really
more than
is that
900
really
kilometers, more than
is that
900
really
kilometers in the north-south, no, south-north direction, and our angles of the 4 different stops we had matches the 69, or we use kilometers, so 111.1 kilometers per 1 degree per 111.1 kilometers.
So when you took those measurements, though, it was pre-assumed, it was already known that you live on a globe, so there was no question. They didn't give you a choice.
The angles didn't lie.
That's what I'm saying, bro. Do you get what I'm saying though? Like they took your observation and they pre-assumed you're already on a ball. Like they didn't prove you were on a ball first. They just told you were.
What we did was we did those measurements and we used geometry and tried to figure out what shape this would conform to.
Why would you need to even think of being a shape? Why would that even be necessary to think that you would just be floating in space? Like what moment? That's what I mean by self-evident. You tell me the moment that you realized that all your observations growing up are all wrong, that you're actually spinning, and that everything in the sky is an illusion. Like that should be a pretty big moment. If you live in reality,
I've been
that would be a
amateur
moment that
astronomer
you would
for
remember.
quite a long time. And as I said, we did those measurements in the late 80s via my astronomy club over that distance. So we had measurements, and we used those measurements to try to figure out what kind of geometry matches the measurement with it. And luckily enough, from 62 degrees to 69 degrees, at that high an angle, reflection is minimal.
And from my understanding, that can all be explained. That can all be explained on a flat, motionless plane. There is no kinematically. There is no difference. Everything in the sky is moving because everything in the sky is moving. All the angles that you take are all the angles that you take. Yes, but you're already on a ball. You see, they've already put you on a ball to make those measurements. They never said, "Okay, we're going to go find out if there's curvature." Like that would be something that we should have done when we were like kids or whatever and went on a field trip. Let's all measure the curvature of the Earth. Like that sounds like something you would do in school, but we never did. 8 inches per mile squared. Like I didn't even know that thing was a thing until like 10 years ago. So that means they've been definitely hiding this type of shit from us. You got to wonder why. And all the stuff that I was taught maybe isn't true.
I mean, quite a few youths, at least where I live.
Where do you live? I'm sorry. Where do you live?
In Norway.
Oh, Norway. Okay, cool.
Yeah, and
you get to see the 24-hour sun.
Yeah, I see Polaris easily.
24-hour sun, nice. Right?
No, I'm south of the Arctic Circle, but I spent quite a few years north of the Arctic Circle as I was an officer in the army in the north part of Norway.
Oh, that's super cool, bro. That's nice. So you get a lot of sun. Like, is there a day where you get like more sun or less sun? How does that work?
Yeah, in the middle of the summer, around the 21st of June or so, I think the sun is below the horizon for about 3.5 up to 4 hours or something like that.
So it's just beyond it. So it just looks like it's just right over the alleged curvature or whatever.
Yeah, it doesn't get dark at all.
That's interesting. So it's like but do you see the dome kind of effect that it has, to where it's like you see the light kind of bend above you?
A dome? I don't understand what you mean.
So there's people that have, I mean, I don't know. I mean, it makes sense to me though. Like the pictures that you take in the Northern Lights and whatnot, it looks as though, it's, I don't know, it looks dome shaped.
No, it's like a circle.
Yeah, so the sun is barely. So in my flat Earth mind, it's past the horizon, right? So it's too far away, and it's just kind of lingering, right? And
if you're far enough north, let's say towards the North Pole, and you have the Borealis, you would just see that as a circle above you. Say you do the same at the South Pole.
Don't get me started on the South Pole. No, I'm just kidding.
I mean, I have a neighbor. She lives about 400 meters from me, who skied to the South Pole last year.
Is it a bunch of rivers that are flowing in 4 different directions? Big ass black rock mountain?
No, her name is Marte Brandefur.
I think I found the video, by the way.
Theater, by the way, and it was all pumped up. I loved going to watch that movie. That was another memory in childhood of a moment of going to the movie theater with Bill and Ted's. Like, it was hyped up. It took me a minute to realize that George Carlin's in it, you know? Because when I watched it at first, you know, I didn't really know George Carlin, but then I started watching his comedy after that.
Dude, his last stand-up comedy was so good.
He was ruthless.
So good. He talked so much crap about President Bush's mom.
Dude, he woke me up. He made me an atheist, actually. He got me to believe that there was no God. But he made good points. Like, you gotta admit, I was George Carlin to, you know.
But when they make you an atheist, then sometimes, not saying you, but sometimes the state becomes your God, and that's weird.
Yeah, that never happened to me. I think mine was just more of a, I don't know, man. I just knew that something wasn't right, I guess. It's kind of hard to go back to that moment because,
Well, you can believe what you like. Freedom of religion or freedom of no religion.
as long as you are not impeding my inalienable rights, which are God given, as long as you don't impede on that, I'm good with you.
Well, you just said something that confuses me. You said God-given rights, which that's something I hold to be true, but if you're an atheist, how do you have God-given rights?
No, he's in my life now.
Oh, okay. That makes sense.
Yeah, I'm not an atheist anymore, bro. Like, that was me. That was what? When did Carlin come out with the jamming in New York, or whenever he talked about how God doesn't exist? Whatever year that was. I think I was maybe 14 or 15. I was like, yeah, George Carlin, you're right. Fuck the government, you know?
Well, he did actually somewhat co-star in that movie Dogma. You know, like
yeah, I
Buddy
remember
Fred.
that too.
Yeah, and even though if he was alive today, he would probably be considered conservative compared to the fucking nutcases that are walking around nowadays that are like, oh, liberal and hyper liberal. Yeah, it's
Dude, his jokes about NASA are hilarious. He was on to something because he knew that NASA was full of shit. He had several jokes about it.
he did. I think it was a 10 or 15-minute presentation on a kids show showing about the nonsense of the moon landing.
that was Mad TV, and yeah, it was a skit on Mad TV. Hi, kids. Yeah. Yeah, we had a video store that was like 2 blocks away from my house. And I fucking lived in that place. Like, I was there almost every day. And so I was getting all the movies, and George Carlin comes up. And I was able to get rated R because my mom gave Ed the okay to give them to me. So I rented out George Carlin, and I watched the first one. I can't remember what that one was called. I think it was the 70s one when he was in like in a blue sweatshirt. And there's a joke about a place to hold your stuff or whatever. I need a place for my stuff. We're gonna go over to across the island to Maui to a friend's house, whatever. Oh, now what do I bring? But dude, after that, I was like, dude, I got to get every single thing from this guy. I ain't never heard anything like that before. You know what I'm saying? And then he started coming on HBO.
I'm not so sure that George Carlin didn't believe in God.
I don't know, man. There's something inside of me that makes me think that him and God made like a Lieutenant Dan moment, where he kind of just jumps out into the water and like they forgive each other or whatever.
I think he was against hypocrisy and against controlling people's minds with religion.
Yeah, and NASA.
He may not have believed in the biblical God. He was just talking out against. He said he wanted to remake the 10 Commandments, and the last commandment was keep thy religion to thyself.
Yes,
which is don't push your religion on me. That doesn't mean he doesn't believe in God. He just doesn't believe in pushing your religion on other people.
The Bible doesn't believe that either, by the way. It says to give someone the information and basically move on. It says move on to the next
I think that's where I was at too. Now that I think about it, I think that's kind of where my head was at as well. Like I wasn't really necessarily an atheist per se, but I was just knew that whatever the religion was, I have my doubts about Catholic religion, but I'm not shitting on anybody, but I'm just saying, as a kid, it always creeped me out for whatever reason. I hated going to that church. But let's see, neither.
Wouldn't you say like the definition, ironically, the definition of evil is taking advantage of man's natural spirituality with some kind of indoctrination that isn't necessarily true?
And
well, I think
what's
even worse is using it as a shield, right?
Using it as a shield, false answers, deception. Like that's where it all stems.
Profiteering on the name of God. Come on.
Jewelry.
Mixing the religions.
Indulgences.
The dirty
What do you think about that? The claims of salvation, like as far as the Bible is concerned, it's like a sort of it's trying to compel you into a sort of a reason. It's not just sort of like I appreciate where you're coming from, Larry. It's like you tell people the good word, and like if they're not sort of appreciative or receptive to that, then you move on. But I just wonder whether or not this idea of like damnation is a sort of like it's sort of trying to compel someone into believing in it, right?
Yeah, like if you'll notice, I'm not in here, pushing the book of Matthew every day, right? It's because you've heard about Christ at this point in your life, and we all have the internet now. So, like saying that you haven't heard about Christ. Oh, let me tell you about this carpenter dude. He had some really cool philosophy. Let me tell you about it. Like you already know, bro. And if you don't know, it's because you don't want to know. So it's willful ignorance, which we were told to be wary of willful ignorance. And Jesus said literally, go from town to town, be harmless like a dove and wise like a serpent, and kick the dust off of our heels. In other words, knock the dust off your shoulder, like sweet, sweet. Like that's basically what he was saying. It was like a euphemism for that. And go to the next town and preach it. But this was like 2,000 years ago. Like, you guys already know about the Messiah, and you either accept it or you don't. So I'm not here to like cram it down your throat. That'd be weird.
Is that where the idea of the Mormons and knocking on doors sort of came from? This idea of going
I think
town
those
to town?
guys work with intelligence. In my opinion, they're gathering intel and using it as a shield, because freedom of religion means I can go door to door and be like, hey, who's in here? How many people you got in the house? Do you got any daughters?
That's a rabbit hole for sure. I think, dude, if I remember correctly, Hank, I think we went over this before. Do you remember?
I'm not sure that I remember that.
Do you think if there was a Messiah, don't you think that there was a Messiah named Jesus, or if there was a word that's supposed to be spread, it might have been something completely different than what we're told? Like believing in him is going to get you there doesn't make any sense. Believing in whatever doesn't make any sense. Believing in general doesn't make any sense because beliefs are like subjective and they can be changed, and then they have to become faith, and then you're locked in, and then you can't have any new information that challenges it. So all those things are things that lock you into some kind of like you have to be this way forever, or you're going to hell. Just the threat of hell or the reward of heaven. That's all fucked up too. Because if you're doing anything just because of reward or punishment, then you're not doing it for the right reasons. It's the whole doctrine that's got you everybody in this like false state of fear or greed in a way. It's like a competition with each other. I'm going to heaven, you're not going to heaven because I did this and you didn't do this. I mean, that is separation. I think they use it to separate us just by saying God's outside of us. God's within us. God's what binds us. God's what makes us all one. Not competing with each other for everlasting life or hoping each other get damned forever. That's just the psyop part of it, I think.
I agree. There is a divide and conquer strategy. When I listen to Muslims and Catholics talk, they don't fucking like each other very much. One is saying, hey, no more free speech. That's hate speech. You can't talk about my prophet like that. And then the one's like, Muhammad did this and Muhammad said that. They don't get along. But I think the core principle is what Christ taught was carry your cross, right? And others' cross, which means don't just be a slouch. Carry your burden and carry the burden of others. And don't adhere to the government because the kingdom is within. The God is within. And we're all extremely powerful in the sense that, yeah, they can kill us, but they can't stop the idea of the high priest, Yeshua, is also the high priest and he's a priest king, basically, right? And that puts everybody else equal under him. There's no classism in Christianity. Like if you're a Christian, there's God, then Christ, and we're all equal. And a lot of people have this like weird notion that some people are more equal than others. And that kind of does away with that. So he was railing against the government and the powers that should not be until they killed him. And he said, hey, be like me. Do what I do. Like, don't let people rule over the other people with an iron fist when we could get together and feed the needy and visit the people in prison and that sort of thing. But I'm being long-winded and you guys asked, that's why I brought it up.
Dude, you're fine, bro. Like, I have no problem with you telling me that. That was great. Learn something new every day.
So yeah, I'm not pushing it. I'm just sharing. Do what you want. Freedom of religion. You got 100 years to figure it out. Good luck. That's my philosophy.
And what you were just saying is not what you hear from a lot of people about Christianity.